Welcome everybody. We are working on the mystery of the two planets activity, practicing our explanation task. You should look back at the question if you need to, but we've got here two planets, Ursula and Triton. We have a little spacecraft that is somewhere in between them, and that I am trying to use the fact that I know my distance from the planet Ursula is bigger than my distance from the planet Triton, and the fact that the net force on my spacecraft is 0 to figure out which of the planets has a bigger mass. To do that, I have written down a whole bunch of possible physics models as equations over here that I'm going to think about and try to draw on. I'm going to start by considering Newton's second and third law here. And my initial sense is that because I know the net force on a single object, the spacecraft, that I'm likely going to want to use Newton's second law here to try to tell me what's going on. I'm probably not going to need Newton's third law because it concerns two objects acting forces on each other. And here I have two different objects, the planets, acting forces on the same object. I'm almost certainly going to need my model for the gravitational force overall. This is not a situation where I'm really thinking about energy, so I don't think I'm going to need energy. By the way, it's always possible that we could revise our initial thinking as we get into the problem. Looking down here, I also don't think I'm going to need any kinematics. So my last choice is between these two different models that we have for calculating the gravitational field. One is the model that lets g be a constant. It's the model we use when we are close to, for example, the surface of the Earth. Whereas the second model is the universal gravitation model and is what we typically use when we are farther away or changing distances from a large body. Here, because I have two planets, I'm in a spacecraft, I'm far away, I'm likely going to want to use this model rather than the near-Earth one. So now that I have a good set of building blocks, Newton's second law, the model for the gravitational force, and the universal model for gravitation, I want to put those together to see what that could tell me about the masses of the two objects. Again, I'm going to start by thinking about the net force being 0 on the object. Here I have two planets that are acting two gravitational forces, so I could do something like Fg from Ursula minus Fg from Triton is going to be equal to 0. I know these forces point in opposite directions because the two planets are in opposition to one another, like so. Once I have that, what I can do is use the combination of my model for the gravitational force and my model for the gravitational field to write down the gravitational force on the spacecraft by each planet. That's going to be capital G, the mass of Ursula, times the mass of the spacecraft, which I'll just use ms for, divided by, I'm going to need here the distance between the center of Ursula and my spacecraft, which is du, and I need to square that. So du squared, and then minus g mt ms divided by d t squared is equal to 0. Here I can do some quick algebra to cancel out the g and the ms to rearrange this equation and get something that looks like mu divided by du squared is equal to mt divided by dt squared. From here, what I can do is some proportional reasoning and say what I know is that the distance from Ursula is greater than the distance from Triton. That means that this denominator here is bigger than this denominator over here. The only way these two fractions are going to be equal then is if the mass of Ursula is bigger than the mass of Triton. So I think I can immediately conclude that the mass of Ursula is bigger than the mass of Triton. And the reason for that was that the distance from Ursula was bigger than the distance from Triton, in addition to the deployment of all of these other models. Given that I have the equation staring me in the face here, I can actually do a further level of reasoning to notice that, oh, the distance is squared in the denominator in both cases, whereas the mass of the planets are not squared, which means if the distance from Ursula were twice as big as the distance from Triton, when I go to figure out the mass, I would actually need the mass to be 4 times bigger to compensate for the factor of the extra factor of 2 that I get from squaring the distance, which came from the gravitational field model that we have down here.